Please, I'm begging.
It's
Any question?
f of x equals 14x to the fourth minus 84x squared.
Like this?
Yes.
Okay, what are we asked to do?
I didn't go through the whole thing, but it's the extremas, and I think there's concavity, and
the whole spiel we say. Okay, good,
yeah.
Good. Excellent question. So I will get my table going. I cannot stress enough, if you do not like this table, fine. But if you don't use a table to summarize the information, I will not be able to give credit for this function, for this problem. I do not take offense if you say, I don't like your table, I have my own. Excellent. But you have to be able to summarize the information so I can look at it, so you can graph it. Please. This is a polynomial function, so we know that the domain is all real numbers. That's nice. So I will always start with whatever I can get about the function from the function itself. That's my first step. So when I look at this function, I see it has degree 4. And that implies that it should have 4 x-intercepts. But maybe not. Maybe they're not all real numbers. I don't know. But I need to look for 4. Good. So when I plug in 0, that's the easiest thing to do. I don't really like this. It's not. Okay. So when I plug in 0, I know that the function is 0. How do I know? It's 0, 0 everywhere. Okay, the next step, I want to solve the equation y equals to 0, or f of x equals to 0, which is 14x to the fourth minus 84x squared equals 0. Let's see what I can divide by. Can I divide by 14? So, can I divide by 2? I can divide by 2, and then this will be 42. Okay, so I should be able to divide by 14. So how much is 84 divided by 14? Is it, if I divide by 2, it's 42, and if I divide again by 7, it's 6. So it should be 6. So x to the fourth minus 6, x squared equals 0. Now I will factor out x squared, and I have x squared minus 6. I don't like it. I was hoping for something nicer, but it is what it is. So x squared, and this is x plus the square root of 6, and x minus the square root of 6. You can say you cannot factor like that. We can, but let's say we can just write x squared equals 0 and x squared equals 6, and I get the same thing. So here are the 4 solutions. X equals 0 appears twice. And if you remember from pre-calculus or college algebra, either one, this means a term. But we don't really need to remember that at this point, because the first derivative will give us that anyway. So the other solution is as the square root of 6, and the other one is negative the square root of 6. So I will put those in. 0 is already there. I have to put the square root of 6 and the square root of negative the square root of 6 and 0, 0. So I know that this will be either a max or a min, but don't worry about it. The first derivative will give us all the information. The other thing I need to determine are these limits. And there is nothing else I can find about a function from the function itself, but I need those limits. Okay, so limit as x approaches negative infinity from 14x to the fourth minus 84x squared, and the limit as x approaches infinity from the same thing, 14x to the fourth minus 84x squared. Okay, since at infinities, where are my props? At infinities, not anywhere else, but at infinities, these terms don't count. They're too small. Only the highest degree counts. Fine. So in that case, when I plug in negative infinity and I take it to the fourth power, it's going to be positive. Same thing here, positive. I go back to my table and put positive infinity and positive infinity. And this is it. Even if the problem in MyLab Math does not require you to determine all these, we have to determine them. Because we're going to graph. And it's a perfect example, we're going to graph this one. Even if the problem is not asking us to graph, we will be asked to graph on the final exam. Okay, so now I'm going to move on to the first derivative. So f prime of x is 14 times 4, 56x to the third minus, I think it's 168x. Right? 160, 168, yep. And I know there are no critical numbers coming from f prime being undefined. So the only critical numbers will come from f prime being 0. And I have 56x to the third minus 168x equals 0. Stop me if you have any questions. Anything so far? I'm sorry, I should have stopped. Anything so far? Anything? Okay, so I would like to see, is this 3? Oh, look at that. Look at that. 3 times 6, 18. And yep, I will definitely divide both sides by 56. I want it out of there. X cubed minus 3x equals 0. I factor out x. Although this is not that nice. It's degree 3. I'm expecting 3 solutions. And the solutions will be x equals 0, x equals the square root of 3, and of course negative the square root of 3. Go back to my table. The square root of 3 and the square root of negative the square root of 3. This is smaller than the square root of 6. So these are the critical numbers. I put them in the table, and I have to study the sign. Of what? Of this. Better of this. You don't have to. You can just put it in the graphing calculator and punch in numbers. So if I select negative 10, this will be negative, this will be negative, and this will be negative. So 3 negatives. Now I'm in a little bit of a trouble, but I can still plug in negative 1 because this is negative 1.7. Negative 1, negative, negative, negative 1. This is positive. This is negative, positive. The function is even because when I replace negative x by negative x, I get f of x. So all this side has to be the same sign as this side. So when I plug in 1, it's even. I'm checking. That's why I'm checking just to make sure. When I plug in 1, this is positive. This is positive. Oh, no, this is. So how come? Hold on. I'm thinking for a second. The function is even. When I replace x by negative x, I get the same thing. It's symmetric with respect to the y-axis. And why am I getting here negative? When I plug in 1, I'm getting negative. Oh, yeah. I'm sorry. Yeah, that's correct. It's about the first derivative. That's why. I was thinking about the function for a second. Okay, that's correct. So now 10, positive, 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 everything positive. Good. At this point, moment of truth. If these two rows don't go well together, I'll say, uh-oh, I have to go back to the drawing board. I'm checking now. From positive infinity, oh, I have to find these numbers first. So I have to find the function value when x is the square root of 3. or negative the square root of 3, the number has to be the same. So f of the square root of 3 will be 14. The square root of 3 squared is 3. 3 times 3 is 9. Minus 84 times 3. I'm lazy, so I have to put the calculator in motion now. I thought I would avoid it as much as possible, but it's not working now. Negative 120. I don't want to waste your time. Okay, so negative 128 for both, guaranteed. Negative 126 for both. Because the function is even, as I mentioned here, even function. Symmetric with respect to the y-axis, mandatory. Okay, so now I'm checking my two rows. From infinity to 0, is it decreasing? Yes, it is. From 0 to negative 126, yes, it is. From negative to 126 to increasing to 0, yes, it is. From 0 to negative 126, yes, it is. From negative 126 to 0, yes, it is, and yes, it is. So these two work fine. Finally, we have to look at the second derivative. Where is my first derivative? Right there. So the second derivative will be, so that's 168 again. So x squared minus 168. They must have worked very hard to give us these nice numbers. So when the second derivative is 0, I get that x squared minus 1 is 0. Or x equals plus or minus 1. Wow. But that messes up my table completely. Because 1 and negative 1 will be here. I'm going to try to squeeze them in with my apologies to you. I should have left a little bit more room. Sorry about that. It's a quadratic function. When I plug in 0, it's negative. And outside is positive. Holds water and does not. If you want to use the second derivative test to check, it's very nice. This is obviously a local min, and the function opens up. So it has to be a local min. Here there is opens downwards. So obviously, because of the sign sequence like this, positive, negative, this is a local max. And the second derivative verifies that. Here, negative to positive, this is a local min. Obviously, it's correct. Also, I have to determine this value for negative 1 and this value for 1, because those are the inflection points. So there have to be the same value. So it's basically 14 minus 84, which is negative 70. Negative 70 and negative 70. I can create write the table one more time if you think it's not readable. I do not have a problem recreating the table on the next page, just to make sure that it's clear for everyone before we graph. So my problem was that I didn't leave enough room between negative the square root of 3 and 0 to insert the negative 1. So this is the inflection point here, IP, and this is another IP. Should I rewrite the table or not? Or you are okay with that?
Yeah, could you possibly rewrite it?
Yes, it will only take a blink. It's really not a problem. That's the problem. I cannot always prevent that from happening because I don't have the advanced results. I cannot get the second derivative. And I don't want to wait to find the second derivative to go back and start my table. I cannot do that. So all that, as I said, it will take a blink for me to just make sure that leave enough room. So negative infinity, negative the square root of 6, negative the square root of 3, negative 1, 0, 1, the square root of 3, the square root of 6, and infinity. And now this is all I needed. So f prime of x, f of x, and the second derivative. And I'm just copying, I'm copying the zeros here, and here, and here, and the signs. and then I'm copying infinity, and then 0 here, and negative 126, negative 70, 0, negative 70, negative 126, 0, and infinity. And I have 0 here and 0 here, and the signs are these. That's it. So now, even if the problem is not asking us to graph, we're doing all this for graphing. So let's graph it. I have to think for a second because I have to go to negative 126, the smallest, and okay, negative 126. I'm going to take a different scale on the x-axis and the y-axis. So 50, maybe 25. 25, 25, that's 50, that's 100, and 25. So this is negative 150. Okay. And negative 70, this will be somewhere here. And that will be negative 70. Okay. So I'm going to plot my points. Negative 1 and positive 1. So this is 2 and 3. And 2 and 3. The square root of negative the square root of 3 is 1.7. Well, negative 1.7. So this will be here. And this will be here. Okay. And what is the square root of 6? It's 2 point what? Lazy. That's me. 2.4, roughly 2.5. Okay. Okay, so these are the first points. Okay, I'm going to use blue. So this is the first point. The x-intercept. Here's another x-intercept, and here's another x-intercept. These three. Now, the square root of 3 is negative 126. So right here. And everything symmetric on the other side. Okay. At negative 1 is negative 70, and positive 1 is negative 70, of course. Okay, I'm ready. So the function is opening up, coming from positive infinity, crossing at this point. Fine. Still opening up, but this time coming down to a minimum. So this is the local min. Let me write those again. So this is the inflection point. This is a local max. This is an IP, and this is a local min. Okay. So coming down to the local minimum, where it starts increasing to this point. And this point is an inflection point. So now it changes concavity, increasing to the origin. The rest of the graph, I don't care. I don't need it anymore because I know the function is symmetric with respect to the y-axis. So the rest is redundant. Good. Very good problem. So this is 14x to the fourth minus 84x squared. Can I determine the range of this function? Of course. Negative 126 to infinity. Very good. I thank you very much for the problem. Other questions for me? Anything else? Anything else? Any questions about this or any questions about anything?